Hey guys, welcome back. Today let's master Codeforces 2031C-Penchick and BBQ Buns. Penchick loves two things, square numbers and Hong Kong style BBQ buns. For his birthday, Kohane wants to combine them with a gift. In BBQ buns arranged from left to right, there are 10 to the 6 available fillings of BBQ buns, numbered from 1 to 10 to the 6. To ensure that Penchick would love this gift, Kohane has a few goals. No filling is used exactly once. That is, each filling must either not appear at all or appear at least twice. And for any two buns, I and J, that have the same filling, the distance between them must be a perfect square. And so, what is this saying? Basically, what these two conditions are saying is, given like an arbitrary length, let's just say this, we must use a filling at least twice. So we can use them like this, or we can use them like this, or however. We cannot have a filling just on its own. And then the second condition is, where can we put those fillings? So the distance between them must be a perfect square. For example, the easiest example is just right next to each other because they have a distance of 1, and 1 is a perfect square, right? And then something like this would be invalid because they have a distance of 2, and 2 square root is like 1.414, which is just not a perfect square. And by seeing this, you can kind of gauge how to build even cases very easily, right? We can just simply abuse the fact that numbers next to each other will have this perfect square. And these will all have a distance of 1, which are perfect squares. So let's just code that in real quick. If in mod 2, we just pass for now, we'll implement that later. Else, we can define a toPrint variable. And then iterate through for I in range. We go from 1 to n, double divide by 2. And this is because we can just append the same number twice. So toPrint.append I twice. And then we simply print toPrint. And don't forget to unpack it. There we go. Now, we've basically simplified this question into like, what is the odd behavior for these BBQ buns? We know that we can never just like append a 5 or like append an extra flavor because we need to use each flavor at least twice, right? So what this question actually turns into is, how can we arrange these numbers into we use one of these flavors 3 times? And this is difficult because if you can see, these are a perfect square. The next perfect square is 4, right? So if we do like a 3 gap, bang, the distance between these would be 4, but the distance between these is 5. These two are perfect squares, 5 is not. So this is not actually a valid placement. What we can do though is we know for sure that we'll have some like distance between where our numbers are placed that are perfect squares. So if we just imagine that, let's call this x, and then we have some range like j, and then we'll have a y, and then some range k, and then we have a z. We know these are perfect squares. And then this range, let's call this JKL. JKL here are all perfect squares. Now, if we were to write this out in an equation, we get something like y minus x plus z minus y is equal to z minus x. Right, pretty self-explanatory. This distance plus this distance is going to equal to this L distance. Now, if we were to just plug in these variables, we can, to make it like easier to see where I'm going from this, since we know j, k, and l are all perfect squares, let's just call this a squared equals j, b squared equals k, and c squared equals l, right? If we were to replace these like y minus x with j, k, l, we simply replace them with a squared, b squared, c squared. And this turns into a squared plus b squared equals c squared. Whoa, doesn't this look familiar? This is simply just the Pythagorean theorem, right? And from just simple geometry, we know that the smallest numbers that kind of fit this pattern perfectly are 3 squared plus 4 squared equals 5 squared, or like the, oh my god, I cannot draw. 3, 4, 5 triangles, right? So that's kind of how we solve for these distances in between. We know that they should be 9 and 16 now. But since we're like doing one, we're gonna have one like hold the spot. The actual distances between them are 8 and 15. And so now we know where to place our ones, right? We simply just put them in spot 1, spot 9, spot 9 plus 16 is 25. There's some gap here that I'm just not going to draw out every range. And this case here, since it's even, makes it very easy for us, right? Remember our even behavior, we can simply just abuse the fact that numbers next to each other will have a perfect square of one distance. So we can just do 2, 2, or like, yeah, 2, 2, 3, 3, 4, 4, 5, 5, and then this should be 8. We fill out all this perfectly. Now this is kind of hard because this is odd, right? So how can we fill this out? Because we can't just willy-nilly fill it out with evens. Well, how can we make this even? We can make it even simply by appending another number. Like, for example, I ended with 6. We can do 6 here and 6 here. And then since these have a distance of 15 between each other, these will also have a distance of 15, which works out kind of perfectly. And then this gap here suddenly becomes 14, which is an even number. So we can then again use this strategy, 7, 7, 8, 8, 9, 9, yada, 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 to fill out the rest of this array. And now we kind of have this hard-coded block that for every n that is less than like this, okay, this block range is going to be 26, right? Let me think. 1, 2, so it's 1, 9, 15, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15. It's going to be 27, right? So we'll have this hard-coded block for all digits from 1, or all in from 1 to 27. And this will specifically work for odd numbers because we have a different behavior for even numbers. Now, this will also tells us that if our number is less than 25, because that's where our repeat happens. Our repeat happens on the 26, on n equals 26. Or I say repeat, but I mean like the third, the first time we can place 3 of the same flavors happens on index 26. Then all odds before 26 So if n is less than or equal to 25, it's impossible. So print -1, continue. And now we have this sequence, right? We know this sequence. We could write a script to generate it for us, or we could very simply just hard code it. It's only 27 digits. This is perfectly valid. So we have this pattern equals, and I'm going to copy and paste this and not type it out because that will take a lot of time. But yeah, if y'all just want to take a sec to view the pattern, we see that the 1 goes in slot 1, and then there are 8 digits in between. And then at position 9, we have another 1. And then there are 15 digits in between, and then we have another 1. And then we see that behavior 2 is a little bit different. Right? It's right after the 1, so that this gap here is 14. And then we place the 2 after, so that the gap between the 2's, from the 7 all the way down to this 1, is also 15. Now, what we need to do after this, though, if we have larger n, so n that's like greater than 27, say like in 31, in 35, etc., we still need to append to our pattern. And we can do that by the same way as what we're doing down here, just appending 2 numbers equal to each other for each block. Since we've already taken care of the use a number 3 times, this will always be odd, right? So same code we have here. Let's just copy and paste it, copy all of this. Since our thing is called pattern now, let's call it pattern, except we start from, this ends at 13, so we start at 14, and then yeah, this should just be the code. Let me get rid of this white space. So just to recap, if it's even, we go through this even behavior of appending 2 of the same next to each other until the end. And if it's odd, if it's less than 25, it's impossible because we cannot put 3 of the same flavor down within that range. And if otherwise, we have this hard-coded start that allows us to place 3 of the same flavor within this range. And any additional counts after that, we can put the same number next to each other to fill in the rest. And yeah, that's my code. This is what I submitted, which if you see and I run it, works perfectly. This is less than 25, so it prints -1. This is even, so it does the 2 of the same trick. And if we test one more case, let's just test 31, just so y'all see. It copies pattern perfectly all the way up to 13, 1, 2, and then for each number after, we append 14, 14, 15, 15. There we go. And that is the solution to this question. If y'all enjoyed this video, be sure to like and subscribe. I will see y'all guys next time. Bye.